Substructures is headquartered in Portsmouth, New Hampshire. This is a vessel under construction. Most of the work that we do related to multi-beam work is only possible because we put all the time and energy into designing and developing this vessel for the application. Baseline of the work we do is marine construction. We've had a need for doing high-resolution scanning work for underwater applications, marine construction, demolition, debris removal, dredging, and the pile driving work and pier construction and so on. Regular surveys along the waterfront, most people will have a single beam survey done. Costing wise, it's significantly less than a multi-beam. Quality wise, it's significantly degraded from what you can get from a multi-beam. There are specific angular uncertainties that are inherent in single beams that cannot be calibrated out. Because the multi-beams, by its name and nature, has multiple beams, you can actually do offset passes overlapping the beams that allow you to calibrate the system based on the georeferencing of the vessel and the motion control system on the vessel. The process started out with a hull twisting analysis to make sure that the vessel was stiff enough to handle the high resolution sensors that we were putting on there. By the time Andy and his team finished up with the design process, we were able to use a modeling program that assumed under normal survey conditions, which was sea states less than up to 3 feet and our survey speed of 6 knots, that we would keep the hull flex end of the ship to less than 1/100 of an inch, and that produces, again, the reliability and predictability of the data that we're collecting. So welded aluminum hull, went into paint, got it out of paint, put some glass in there. We received it in the middle of winter, tough place to work on it. So we, being of limited resources in space, we did what we could, jacked it up, stuffed it into the building, and that's where it sat for about a year while we were doing all the finish out work on all the mechanical systems in the vessel. The vessel has a medium speed tractor jet, which provides incredibly smooth propulsion, very low vibration, and very predictable data quality. All the surfaces were sprayed down with urethane material and then covered with dual density foam to eliminate vibration and noise problems. Every single component in the vessel is soft mounted to further reduce vibration problems, compressors, engines, anything that's energy producing. Very tight electrical systems. Every single connection, both AC and DC, is crimped, soldered, and adhesive line shrink tube to make sure that there's no voltage leaking. Separation of AC/DC and signal lines throughout the vessel is extremely regimented. We went through a whole process of eliminating all the possible electromagnetic interference that may screw up signal cables. And it's just a nice, neat, clean design specifically for the purposes that we're doing. The vessel's trailerable, so we can take it pretty much anywhere. And the finished package is something like this, with all the systems jammed underneath the flush deck, so we can actually have good access to the back. We can actually put ROVs on the back, divers. We have an A-frame that works off the back, joystick controls for the hydraulics that run directly off the transmission, so we've got live PTO and power all the time. And the hull characteristics at its survey speed are spectacular. We're at least almost perfectly flat in the water, so we have very little lift and squat issues during our survey operations.
The scanner is actually controlled through the software, and the multi-beam system has its own interface, which you can control the settings, the opening of the aperture, range settings, power gain. That stuff is controlled through the software itself, through its own software. The collection software then lets you see what's going on. So right now we're just sitting at dock, so we're getting a scan, but we're just getting the same scan over and over, we're not actually moving. And so once you start recording, you actually start painting the chart over, so you can see the broad NOAA basis. There's a channel line, and then there's a shoaler in the cove, but now you can zoom in as we paint. Real time, see the bottom. You get a few errors from the laser depending on how you are in the sun. There's a lot of shimmering going on right now on a bright sunny day. So you need to get some errors.
How deep can you go with multi-beam?
This particular system in its 200 kilohertz frequency is good to, its ultimate's probably 1,500 feet. And that would be directly beneath the boat within the swath range. The outer ranges are gonna pull in, and you'll only be able to get that concentrated area underneath. Good operational range would be 1,000 feet for good broad surveying at 200 kilohertz, and then probably 100 meters for the 400 kilohertz.
But that should get you, I mean, most of the stuff you're doing is near shore.
That's all shore. Yeah, we want to use the higher resolution. The good thing about this is it's a variable frequency system, so we're able to tune it specifically to tune out other vessels that are on the water. So most people are running either a 50 or 200 kilohertz sounder on their boat, and we can tune it in 10-degree kilohertz increments that allows us to kind of tune out the other vessels so we don't get any acoustic interference with a multi-beam system. And that's actually a very, very nice feature of this system.